This is Math 102 College Algebra, and we are starting today Module 1. Module 1 is all concerned about solving linear equations. So before we even actually get into the work, we first need to go over some definitions, some vocabulary of words you're going to be hearing me say. So let's go to the PowerPoint. Okay, if you recall from your knowledge of algebra, an equation is a mathematical statement. It's a sentence. And an equation contains an equal symbol. So when you have an equation, you have an equal symbol. And that means there's a right side of an equation and a left side. And on the right and left side, there could be numbers, there could be variables, letters, and then there's operations that put those numbers and letters together. So if you look, x plus 7 equals 9 is an equation. 3x minus 1 equals 5x plus 6 is an equation. It's an equal sign. It's an equality. You want to make sure you keep both sides equal at the same time. They're balanced. Now, we don't have to use the variable x, but in most algebra books, that's the variable they use with equations. Okay, one of the things we're going to be working on in this module is linear equations. So you have to know what a linear equation looks like. An equation has an equal sign. To be linear, the variable has to have an exponent of 1. So in a general form, a linear equation is ax plus b equals c. The a, the b, and the c, there would be numbers in those positions. If you look, the only variable is an x. And if you look closely, that x doesn't have an exponent. So it's understood to be the number 1. So a linear equation, all the equations we solve in this module are linear. They all have x's with the exponent of 1. Now, why is that so important? Because when we solve an equation, we get our solution, our answer. And with a linear equation, that solution, there's only going to be one answer because the exponent is the number 1. So the solution set to any linear equation is one solution, one answer, one number that makes the equation bounce. When you hear, the main direction you hear when you're working with linear equations is the word solve. Solving means one thing and one thing only, to isolate the variable. Isolate means to get by itself. So when you're solving an equation, you want the variable x on the left side, and you want on the right side of the equals a number, what it represents. Now, there is a correct process to follow in solving linear equations. Many of you guys come from different backgrounds. You may have learned this procedure differently, but I'm telling you, if you always want to solve a linear equation correctly, you will follow these same 6 steps. The first thing you want to do is get rid of parentheses, and we're going to discuss that in a minute. To get rid of, you're going to distribute. Then if your equation has fractions or decimals, you want to get rid of those too, because you only want to work with whole numbers, integers. Then you want to make sure on both sides of the equation you collect like terms. Put together what's the same. After you do those 3 steps, then you start the whole moving process, moving the variable to the left, then move the numbers to the right. And if you always keep that motion, variables go to the left, numbers go to the right, you'll never make a mistake. And the last thing you want to do when you're done solving a linear equation is check it. Make sure you got the right solution. And that's what we're going to go through now. So, in the notes I have 8 examples. We're going to work these examples on the whiteboard to make sure you understand. So let's go to the whiteboard. Okay, if you look up here, here are the first 4 linear equations. Again, they're equations because they have equal signs. They're linear because if you look at the variable x, there's no exponent written. It's understood to be a 1. Understood to be a 1, and a 1, which means you're only going to have one solution, one answer. Now, what's very important is you could think of the equals as a wall. It separates the left and right side of an equation. So every linear equation has a left side and a right side. What you want to do is you want to isolate the variable. You want the x on the left and the numbers on the right. So if you look here, the x is already on the left. And in fact, with all four of these linear equations, my x is already on the left. So I don't have to do anything with the x. What I have to do is move the numbers or the constants to the right side. And the way you do that is you do the opposite operation. If this says to add 4, to move it, you would want to do the opposite. The opposite of adding 4 is subtracting 4. And because an equation has two sides, it's got to balance. So what you do to the left, you do to the right. Now that's important because it relates to real life. You can think of real life equations in two ways. You can think about it if you're working out in the gym and lifting weights. So if you're working the bar and you add 4 pounds to the left, you would have to add 4 pounds to the right to keep the weights balanced. You don't lift weights like this. Another way you can think about equations being real life is think about the whole idea of going to the play yard and playing on a seesaw or teeter-totter. How many times have y'all seen children and they get on the seesaw on one side and the other side's up here and they don't understand why it's not working? Well, the whole thing about a seesaw working is there's balance. It's equal on both sides. So if you have a kid that weighs 25 pounds on the left, you want to put a kid that weighs 25 pounds on the right to keep that balance. So that's how you got to think of this. Now, I know a lot of you say, well, I can look at this equation and get the answer in my head. That's great. But we got to learn procedure. Because if you do not learn the procedure to solve a linear equation, these baby ones, these little ones correctly, you're not going to be able to do the big ones that are in college algebra. So let's go make sure we understand this. We're moving the 4 by doing the opposite. And add 4 and subtract 4 makes 0. Well, we don't got to write x plus 0 because that means you're adding nothing. So you've learned to just cancel them out. They're opposites. They undo each other. So that leaves us with the x on the left. It's isolated. Now on the right, 12 minus 4 is 8. That is your solution. How do you know it's correct? You check it. You say to yourself, all right, if I put that in the spot for x, if I replace x, if I substitute for x, 8. 8 plus 4, does that equal 12? Yes. Let's do the next one. I want to solve this linear equation. The x is on the left, so all I got to do is move the number. The opposite of subtracting 4 is adding 4. And I do it to both sides to keep balance. Add 4 and subtract 4 are opposites. They undo each other. They make a 0. These were called in algebra additive inverses. Adding the opposite cancels out. Bring down the x. Bring down the equals. 12 plus 4 is 16. There is your solution set. The third equation, it's negative 4x equals 12. Now you have to pay close attention. This negative 4 has to move to the right side. But this is not connected by adding. I didn't say the word add. It's not connected by subtracting. I didn't say the word subtract. We all learned a number and a variable side by side are connected by multiplication. So to move multiplication, you do the opposite, which is division. And in algebra, we use the fraction bar to show division. The opposite of multiplying by negative 4 is dividing by negative 4. And if you remember your rules of integers, a negative divided by a negative makes a positive. 4 divided by 4 is 1. We don't have to write the 1 in front of the x because remember from algebra and arithmetic, 1 times x is just x. So you do the same thing as you did up here. Multiplying by negative 4 and dividing by negative 4 are opposites. They cancel out. On the right side, 12 divided by negative 4 is negative 3. There is your solution. Okay, let's try the next one. It's a linear equation. I have the x already on the left, so I need to move the divide by 4. The opposite of dividing by 4 is multiplying by 4. And when you write 4 as a fraction, it's 4 over 1. So we're multiplying this side by 4 over 1. Multiplying by 4 and dividing by 4 cancel out. That's really 4 over 4, which is 1. We don't got to write 1x because we understood there's a 1 in front there. This is 12 times 4, which is 48 over 1. But we wouldn't write that because 48 divided by 1 is just 48. So what we've reviewed so far is just how to solve a simple one-step linear equation. Now you learned that in Algebra 1. Let's take it up a notch. Okay, let's look at the next couple. I have example 5, 2x plus 3 equals 3. Example 6, negative 4x minus 3 equals 2 minus 3x. Okay, in the notes. So again, we're just reviewing what you learned in basic Algebra 1 to get you to college algebra. There's still equations that have equal signs. They're still linear. It's x to the first power. It's invisible. It's x to the first power, x to the first power. The procedure is, to solve a linear equation, get rid of parentheses. I have no parentheses. Okay? Get rid of fractions or decimals. I don't have that. Collect like terms. Well, if you look here, you can't do anything on the left side. You can't put together a 2x and 3. They're not alike. So we don't have to do the first three steps. Step 4 says move the variable to the left. All right, it's already on the left. Step 5 says move the constants to the right. So if you look, here's the equals. That separates the left side and the right side. What we got to do is move the numbers to the right. There's two numbers here. There's a 2 and a 3. It matters who you move first. Now, it's important to understand this. In solving equations, we move adding and subtracting first. It's the one furthest away from the variable. So we're not going to move the 2 because that's connected by multiplication. And think about it. If you were going to move the 2, you'd have to do division. Well, if you divide this term by 2, then you'd have to divide this term by 2 and this term by 2. Well, that's going to cause a problem because you're going to end up making fractions. So we never move division first. We always move add and subtract first. So the opposite of adding 3 is subtracting 3. So we bring down the 2x, we didn't move it. Positive 3 and negative 3 make what? 0. So we just cancel them out. They're additive inverses. Equals. Well, on the right side, positive 3 and negative 3 cancel out also. But here's the problem. You can't leave the side of the equation blank. Every left side and right side must always have something. So 3 minus 3 is what? Good, it's 0. You must write that. So one of the most important things about solving equations, guys, is you always have to have something on both sides. Now you're not done. X is not by itself. So this is 2 times x. The opposite of multiplying by 2 is to divide by 2. 2 divided by 2 is 1. It cancels out. We don't need to write the 1 in front of the x because it's understood. 1 times x is x. On the right side, you cannot leave 0 divided by 2. We're back to simple arithmetic. Nothing divided among two people is nothing. And yes, 0 is a solution. Is 0 a number on our number line? Sure it is. So it's an answer. All right, let's go to example 6. This one has a little bit more work because if you look, it has parentheses. So the first step in solving a linear equation is to get rid of parentheses because you cannot move the terms if they're stuck inside something. So the rule is to get rid of parentheses, in front here is a negative 4. It is physically touching the parentheses. They're side by side. There's nothing in between here. So that's connected by multiplication. So you learned in Algebra 1 a property called distributing. Distribute means to give to all. We're going to use our distributive property to get rid of parentheses. And I usually make little rainbows here so I know that I'm multiplying. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. The other side, you just bring down. One of the things you're going to learn for college algebra is you got to go step by step and go slow. Try not to do too much at once. The first step in solving linear equations is if there's parentheses, get rid of them. I got rid of them. Step 2 is to get rid of fractions or decimals. I don't have that in this equation. Step 3 is to collect like terms. Well, on the left side, there's a 4x and a 12. They're not alike. I can't put them together. On the right side, there's a 2 and a 3x. They're not alike. I can't put them together. Step 4, move the variables to the left. See, here's the wall. The variable Miss Black's going to move is the negative 3x. Rule: you only move an x in an equation by adding and subtracting. You never move an x by multiplying or division. So to move a subtract 3x, you add 3x. Now when I move it to the left side, I'm going to put it underneath the 4x because they're like terms. We could put them together. You can't add a 3x to a 12. So that's why I'm not putting it under there. Now I'm going to do my work. A negative 4x and a positive 3x. Different signs, you subtract. That would give me negative 1x. The 12 I bring down, and it's positive. Equals. The 2 I bring down. The 3x's are opposites, so they cancel out. I'm not done yet. Now that I got my x on the left, the numbers move to the right. I said I always move addition and subtraction first, so the opposite of adding 12 is subtracting 12. And I'm doing it to both sides. Bring down my negative 1x. The 12's cancel. They're additive inverses. I add it the opposite. 2 minus 12 is negative 10. Now you're still not done. This is not x. There's a negative 1 in front. A lot of you are correct. You don't got to write the 1. You could just leave it as negative x, but you're still not done. You've got to understand if there's a negative in front of an x, that's really the number negative 1. It's connected by multiplication. And to do multiplication, you do division. You've got to show all your steps so you understand the process. A negative divided by a negative makes a positive. That's why we have x. Negative 10 divided by negative 1 is a positive 10. So far we've done 6 linear equations and we've seen each one has one solution. Okay, let's try another one. Okay. Let's go to example 7. 5 times 3 plus x minus 8x plus 9 equals negative 4x. All right, here we go. Let's go through the process. Step 1 is to get rid of what? Parentheses. We have 2 sets of parentheses, so we do them in order. So we're going to distribute. 5 times 3 is 15. 5 times 1x, remember there's an understood 1 there, would be 5x. Now here's where the boo-boo comes in. This says subtract. It's also understood that there is a number in front there. There is the number negative 1. So now here's where confusion comes in because you can think of this as 2 ways. You can think of this as distributing a negative 1. Well, if we do that, what's a negative times a positive? It makes a negative 8x. And it's a negative times a positive, it makes a negative 9. You've learned when you multiply through by a negative 1, all it does is change the signs of the terms. If you read this and say subtract, that's your definition of subtract. Subtract means to make the opposite. The opposite of 8x is negative 8x. The opposite of 9 is negative 9. So I, nor do your teachers, care. Do you think of it as subtracting and you just change the signs, which I did here? Or do you think of it as distributing a negative 1, which changes the signs? Okay? Either way, I'm following get rid of parentheses first. And this equals negative 4x. Step 2, get rid of fractions or decimals. We don't have them. Step 3 now says collect like terms. This is the only time when solving an equation it's mental. There's no work to be seen. Collect like terms means to work with one side and put together what's alike. So I'm about to do this and it's right under here, CLT. Collect like terms. I'm about to put together what's alike. And in algebra, you want your variables first and then your numbers. So if you look, I'm going to put 5x with negative 8x. I'm not moving them, so I'm not doing the opposite. I'm just putting this together. What is 5x minus 8x? That's negative 3x. Then I'm going to collect my numbers, my constants. What's 15 and a negative 9? That would make a positive 6. Okay? So that's the only time there's no work to be seen in solving a linear equation. You're doing that in your head. After I collect like terms, now it's my job to move. I know a lot of you have been taught it doesn't matter what you move first. It does. You should always think about the goal. The goal is to get the x on what side? The left. So we're going to move this negative 4x to the left by adding it. When you physically move a term, you have to show that work. Negative 3x and positive 4x would make a 1x. And we don't have to write the 1, we just write the x. Plus 6 equals. What happens on the right side here? I know they cancel out because they're opposites, additive inverses, but can you leave the right side blank? No. So what do you put? A 0. Good. Now we can see I'm not done. I have x, but it's got to add 6. So the opposite of adding 6 is subtracting 6. So we'd get x equals nothing minus 6. If I have nothing and I lose 6, I've lost 6. I hope everybody's okay so far because I want you all to understand we haven't done college algebra yet. So let's go back to the PowerPoint and let's talk about college algebra. This last linear equation is a college algebra equation. Now look at it good. If you look at it, it still fits my definition. It has an equal sign, so it's an equation. It is linear because if you look at every single x has no exponent on it, which is understood to be the number 1. The problem with this linear equation is it's going to take a lot more steps. Now, you've learned everything you need to learn about solving this equation in Algebra 1. It just looks horrible because it's got many more terms than what you're used to. So all I could tell you on this, guys, is you're going to really have to go slow and be careful not to make a careless mistake, because every single careless mistake you make will make the answer be incorrect. So we're going to work this out slow, but you're going to see by working it out, we're going to still follow those same 6 steps. So let's go back to the whiteboard. Okay. So I have it up here. I will give you a helpful hint. When you're working with linear equations that are this big in college algebra, don't try to work both sides. There's the wall, here's the left side, here's the right side. Let's start with just the left. Let's work this down as far as we can go. Step 1 is to get rid of what? Parentheses. Okay, here is where the parenthesis is. So here's the problem, guys. You're going to have to realize you're going to have to use a lot of paper and copy. Everything in front of that parentheses is going to stay put. So we're going to recopy 25 minus bracket 2 plus 5x. Here's where we're going to get rid of parentheses, and we're going to use what property? Distribute. Negative 3 times x, negative 3x. Negative 3 times positive 2, negative 6. All distributing does is get rid of parentheses. Good. Now, there's no fraction or decimals, so it's CLT time. Inside this bracket, there is 1, 2, 3, 4 monomials. Put together what's alike. So I'm going to leave the 25 in the minus, and I'm now going to do CLT. 5x minus 3x is 2x. 2 minus 6 is negative 4. So far, so good? Now, here's our problem. To get rid of a bracket is just like getting rid of parentheses. So we're going to have to get rid of this bracket by multiplying, distributing. Or you can think of this as, when you read this as 25 minus, minus means, subtract means, change what's behind. So the 25 stays. If you want to put the little negative 1 here, that's great. You could think of it as distributing negative 1, or you can think of it as subtract means change signs. So negative 1 times 2x is negative 2x. Negative 1 times negative 4 is positive 4. We change signs. Now that the brackets are gone, you still have 3 terms, 3 monomials. Who can use CLT? Who could you put together that's alike? You could put 25 and 4 together, and that would make a positive 29. So that's the whole left side worked out. Now we're going to go do the right side, again, bit by bit. We're going to see what happens here. Okay? So first step is to get rid of parentheses. There's 1, two parentheses. We're going to do them in order. So we're going to distribute. Negative 3 times 2x is negative 6x. Negative 3 times negative 5 is a positive 15. We're going to leave the minus. We're going to leave the bracket. Here's our next parentheses. 5 times x is 5x. 5 times negative 1 is negative 5. We're not going to distribute here because it's not a parentheses. We're just going to bring those terms down. Step 1's done. We got rid of parentheses. Step 2 is get rid of fractions or decimals. We don't have that. Step 3 is to collect like terms. Well, inside here, because they're all in that bracket, we can put together what's alike. So I'm going to leave the negative 6x plus 15 and the minus and the bracket. Let's put together what's alike here. 5x minus 3x is 2x. Negative 5 plus 3 is negative 2. Now, the problem is we have a bracket. We can't put these terms with these terms because they're inside a symbol and they're not. So now it's time to get rid of the bracket. You could think of this as subtract, which means change the signs behind it, or you can think of this as distributing a negative 1. What's in front's going to stay, negative 6x plus 15. But negative 1 times 2x is negative 2x. Negative 1 times negative 2 is positive 2. And that's what I did. I changed the sign. I changed the sign. Now that it's free and it's no longer in brackets, we still can collect like terms again. Negative 6x and negative 2x, because they're both negative, we're going to add, make negative 8x. 15 plus 2 is 17. Now, we're not done, but we're getting so much closer. Here's the equal sign. Now that we got the whole left side worked as far as it can go, and the whole right side worked as far as it can go, now we're on step 4. Move the variable to the left. Here's your variable. How do you move a negative 8x? You add it. Negative 2x plus 8x is 6x. Bring down the 29 equals, these are additive inverses. They cancel out, they make 0, and 0 plus 17 is 17. Now, step 5, move the numbers to the right. You move adding, subtracting first, so we're going to subtract 29. Bring down that 6x. There's your additive inverses. They cancel out. 17 minus 29 is negative 12. The last thing to do is get rid of the 6. To get rid of multiplication, you do division. So we divide by 6. We divide by 6. That cancels. 6 divided by 6 is 1x. We don't write 1x. We just write good old x. And negative 12 divided by 6 is negative 2. And we have our solution. So if you look, I followed the 6 steps. I didn't teach you anything new. We followed the 6 steps. The last thing I want you all to understand is when we're in college algebra, every time you solve an equation, you should be able to check your solution. You should be able to prove to me that this is the correct answer. Now, an equation of this size, to check this, we have to do it on paper. We just can't do it in our head. So as we go through this semester, this course, when you're asked to check your solution, you always go back to the original equation. Always. Then you are going to replace or exchange, or the correct word is substitute, the variable x with the answer you got. So everywhere you see an x, we're going to replace it with negative 2, which means I have a lot of copying to do here. 25 minus bracket, 2 plus 5. Up, there's the x. What's going in its spot? Negative 2. But they're side by side. They're connected by multiplication, so I got to know to put parentheses. Keep copying. Bring down the negative 3. Bring down the parentheses. Up, there's an x. There goes the negative 2. I don't need to put another set of parentheses because there's a parenthesis already there. Keep copying. Plus 2. Close it. When you substitute, replace that x with a number, you're no longer doing algebra. This is good old arithmetic. And when you're doing good old arithmetic, you know to follow, please excuse my dear Aunt Sally. Do what's inside parentheses first, then do exponents, then multiply, divide, and the last thing, add and subtract. So we're going to follow that. This is parentheses. There's 2 numbers in here. We need to work that out. So I'm going to copy everything else, which I know y'all don't like. This is where we're starting first, parentheses. What is negative 2 plus 2? it's 0. There are no exponents, so now it's multiply or divide. I see two multiplications here and here. So that's what we're going to do next. So 25 minus bracket 2, 5 times negative 2 is negative 10. Negative 3 times 0 is 0. Doesn't matter if I write plus 0 or minus 0, it's 0. Now, you all know I can't subtract till I have one number in here. Got to do parentheses again. So in the bracket, which is like a parentheses, 2 minus 10 is negative 8. Negative 8 plus 0 is negative 8. 25 minus negative 8. You've all learned two negatives make a positive. That's the definition of subtract. Add the opposite. You could think of this as being a negative 1 in front, and distributing it would make a positive. And 25 plus 8 is 33. Now, you didn't get the number negative 2. When you check, you're just going to get a number. We're now hoping that the right side spits out that same number, 33. When you check an equation in math, it's like checking your checkbook. And I know a lot of us have debit cards now, and we don't do our checkbook very often, but if you were really working on your checkbook, you would add up all your credits, you would add up all your debits, and hope they balance, come out to be equal. Well, that's what we're doing here. We're doing the left side, and now we're going to hope the right side comes out to be that same 33. So we're going to do it again. So what we're going to do over here is first thing we're going to do is substitute. We have an x, 1, 2, 3 places. Wherever that x is, we're going to replace with negative 2. So we're going to copy. So negative 3, parentheses 2, there's the x. I'm going to replace it with negative 2. But they're side by side, so I need to put a parentheses to show multiplication. Minus 5. 5. Up, parentheses. There's an x. I'm going to replace it with negative 2. It already has a parentheses, so I don't need another one. Bring down the negative 1, close it. Minus 3, there's an x. I need to put in negative 2, but they're side by side, so I need to put my parentheses to show multiplication. Plus 3. After you substitute, this is arithmetic. You follow, please excuse my dear Aunt Sally. You do what's inside parentheses first. So if you look, here's a big parenthesis. We're going to do that first. So in this parentheses, 2 times negative 2 is negative 4. Negative 4 and a negative 5. Or negative 4 minus 5. They're both negative. You would add that and make negative 9. Minus bracket 5. Here's another set of parentheses. Negative 2 minus 1. They're both negative. You would add them is negative 3. Now, there's nothing to do in this parenthesis. It only has one number. So you got to remember that. Parentheses means there's several numbers inside. You're working it all out to be one number. After I get rid of the parentheses, there's no exponents, so now it's multiply and divide. I see 1, 2, 3 multiplies. So we're going to do that. Negative 3 times negative 9 is positive 27. Bring down the minus, bring down the bracket. 5 times negative 3 is negative 15. Negative 3 times negative 2 is positive 6. Okay, I can't subtract because there's 3 numbers here, so I have to put those together. So 27 minus bracket. Negative 15 plus 6 is negative 9. Negative 9 plus 3 is negative 6. Up, 2 negatives make a what, y'all? A positive, because subtracting means to add the opposite. 27 plus 6 is 33. There's your balance. When you're done checking, I should see a statement that balances. 33 equals 33. And all that does is prove that your answer, x is negative 2, was correct. When you're solving a linear equation, if you go to check it and it doesn't balance, that means you have the wrong answer. So we just spent several moments here going over how to solve linear equations. We started with a basic Algebra 1 linear equation, and we worked it all the way through what a college algebra would look like. Catch you in the next module.